Hello, everyone. So, since we're in Weiss, and this is the Visual Arts and Music Building, speaking from the visual arts side, it'd be great if we could dim the lights. Art in the dark, for those who did that with Sharon Hirsch. It's a real pleasure to be here. I put a deck, the deck I'm using today is the deck I actually use when I present to schools, graduate schools in architecture, because it's really not just focused on what we do as a practice, but some of the challenges that we're facing in our space, and not just architecture, but engineering, construction, and even the challenges with ownership, with what we're seeing. But sort of to start off with, because I went to Dickinson class of '87, and thank you. When we founded the office about 25 years ago, it was made up of 5 founders, 4 of which had liberal arts backgrounds, except for my identical twin brother who studied structural engineering at Penn State. And I'll tell you some stories there later on. But what's been interesting is as a result of our liberal arts upbringing, we came to this discipline with many different skill sets. And it has really influenced how we've been able to break out of sort of the silo of specialization, which is pretty evident in our profession as a result of the challenges with how we manage risk and liability. And so, if I ever go to a cocktail party, people ask, so what kind of architecture do you do? And we'll do anything, except for single family houses. That's like doing a 10-story building, except you talk about the closets all the time. But the thing is one thing that we really feel is important is the balanced relationship between, guardians of culture and theory and innovation, but also the practice, the means and methods that go into how you do a building. And it's a very challenging space because, as you can see, Dickinson has done a lot of construction on campus. And it's never, no one project is ever the same. And so how you go about managing it. So we are really a generalist practice. We do all kinds of architectures, from arenas to public parks to skyscrapers to headquarters for major tech companies. And we like it that way because it gives us an opportunity to really test out ideas on different types of programs, different kinds of clients. The other thing that's really important is buildings are big. And how you break that scale down, and in a way, make that sort of human connection. And materiality is so much about that, whether it's a brick building or something printed in carbon fiber or 3D printed bamboo, is how you take these materials and really give them a human scale sort of connection, intimacy. The other thing that's really important, and this is something that's sort of evolved over the last 25 years, is how important the built environment is to supporting and creating a resilient community. And actually, our very first project was a waterfront park in Greenport, Long Island. But these are just some of the things that we believe are critical in order supporting a great public realm experience. Obviously, access to quality daylighting or access to nature, biophilia, has become even more important as we've been coming out of lockdown. But things like the first 40 feet, how we experience the urban fabric, and how we scale buildings to the pedestrian, not to the car. So for us, to create really meaningful, wonderful architecture, it's about creating a great public realm experience. So it's whether it's doing an arena in downtown Brooklyn, the way that the Oculus really creates this, it's what we call the arms of Bernini in St. Peter's hip hop style, But at the same time, a place for people to gather and debate, have a conversation. The other thing is there's a lot of infrastructure out there in the built environment that could be reused, readapted, and this is an example of the old Domino sugar refinery plant that is on the East River in Williamsburg, and we remaster planned this for 3.5 million square feet of mixed use. The key to this project wasn't so much the designing of the buildings, it was creating this incredible waterfront park where people could feel connected to the waterfront once again, and it wasn't privatizing the waterfront. At the same time, the buildings, the idea of the buildings not creating a blockage to the community of Williamsburg, opening them up so that everybody had access, whether you lived in the building or lived in the neighborhood. And so in a way, you're framing these moments, but again, looking at how these environments are really scaled for people and experiences. And this park became very important during lockdown, so people could come out and be outside and feel connected. And this was, the landscape architects was Field Operations, and you might know them from the High Line, which is probably one of their most iconic projects. Another project which lay dormant for 4 decades was 6 blocks in the Lower East Side. You can see the Twin Towers in the background. This had been dormant since the 70s because the city and the community couldn't come together to decide what to do with it. And one of the key components to this area was the Essex market. And so the idea was to take qualities that were very much a part of that neighborhood. Some of the things you see in Godfather 2, that sense of connectivity, the way that everybody knew each other, all the stores, and the people lived in that neighborhood, how we can bring that at scale over a 6-block area. So the glue to this whole project was the market hall, which would pass through all these different buildings, either at grade or below grade and connect right into the subway infrastructure. And just so you know, because you're going to see a lot of digital imagery shortly, we do still sketch, and this is a sketch that I did for this project. And it was very important to be able to connect with the community. One of the worst things you can do is over-design something and then say, hey, this is what it's going to look like. There needs to be that feedback loop, that connection with the people who actually live there. And sketching is one of the key ways to do that. But again, looking at how the market became the catalyst for this new district. So it's actually 2 markets, the Essex market and the Lowline market, and the way that the building opens up. And again, in a way, the architecture, the physicalness of the building almost disappears, and it becomes more about experience. Because at the end of the day, that's what people remember. They remember experiences, not necessarily, yeah, they'll go, hey, there's this cool building I saw. But it's what they experienced there that really holds true. And so this is an example. This is the headquarters that we just recently completed in Mission Bay, San Francisco for Uber. And one of the ideas here was, how could we bring the energy of the sidewalk up into the building? So yes, you could take the elevator, but could we connect all the floors through this sort of shared commons, almost taking like the commons we have in front of us, in front of Old West, and turning it vertically and connecting all the different floors together. And we call it, this commons, we refer to it as sort of the front porch. But one of the key qualities of this building is the climate in San Francisco is so temperate. So for more than 3/4 of the year, you can open your windows and you know, let the outside in. So we decided, why don't we turn that commons, that vertical pedestrian space, into a space that could open up to the surrounding community. And so we did a lot of analysis to understand how we would mitigate, you know, the heat that would build up through that space during the day. And what we did was we created a breathing facade. So quite literally in the morning when you see the building, it looks like a clean glass ice cube. And then as the day goes on, the building starts to transform as the facade starts to open up and naturally ventilate the vertical commons. The other thing that was really important about this project, again, was how do we scale to people and bringing in warm materials like wood and terracotta to really create this sense of a scaled, intimate connection. And how those materials are read on the outside of the building as well. So it's not just the people who work there, the engineers who work there, but people even on the street can look through this almost glass-bottom boat right into the vertical commons of the building. And so we've taken this idea of what we call the mid-door space and now have applied it to a new headquarters we're doing for Lassie in Sydney, Australia, where quite literally the whole building opens up to the outside. But what we've done here is we've created a series of 8 villages made out of a hybrid system of mass timber and steel. The steel is the bones that really hold the building up. And then at every tray, there's a 3-story mass timber village. And so really looking at how we can bring these natural warm materials into the work environment, and then quite literally just, sort of stepping it to the sky. So this is like jalousie windows at scale, but they all operate on a BMS system, building monitor system, so they automatically open up to naturally ventilate the workspace. This is a project we recently finished for Syracuse University. It's the first of its kind. It's the National Veterans Resource Center to help support returning vets who want to go to school and their families. It also has a connection with, setting up entrepreneurial programs, but also allowing the building to also be connected more with the campus. There's a 1,000-seat auditorium on the lower level, and then the administrative and support services are on the upper level. But again, using warm materials and transparency on the lower level to really open the building up to Syracuse community. And at the same time, and then this is a view of the auditorium inside and the warm materials, but then on the upper level, creating something that's more inward facing, really there to help support the veterans and their families. And we created what we call a parade ground. And what's beautiful about this is when you're on it, you can actually look back at the old Richardson building, which was one of the first historic buildings built on the Syracuse campus. And then some projects which you may have seen in the news recently, we're doing a bunch of super talls. This is 111 57th Street, which topped out last year. And the thing about this is, we really believe it's important when you do these kinds of projects, it's not just for the people who live there. It's also for the citizens of the city. When you look at the Empire State Building, look at the Chrysler Building, you think that this belongs to the city. And this was very much our thinking when we were doing this project. And again, using traditional materials like terracotta. And it hasn't happened yet, but at night, there's actually a series of lights along these terracotta spandrels, which will light up. So you'll see this sort of feathering of light as it washes over this very traditional material. And then this is the American Copper Building, which we did over on the East River. Here it's dressed in copper. So eventually this building is going to be like the Statue of Liberty and turn green. And what we did here is, because it's 2 buildings, we decided instead of building amenities for each building, we would share the amenities through the bridge. So on the upper level, there's a lounge, and on the lower level, there's a swimming pool. So when you're swimming one way, you see the Empire State Building. The other way, you see the UN in the East River. And then this is a project which we just topped out on. This is Brooklyn Tower. Again, thinking about, the city, the city of New York is really the Gotham. And looking at how we bring some of those qualities back, but also make something that feels timeless. And then this is a project we recently finished in Melbourne, Australia, which is another very large mixed-use project. This started out as a tower, but the city said they did not want any overshadowing of the Yar River, so we turned it into a pair of trousers. But again, the base of the building is all about connecting the public to this sort of park, a civic gesture, and then as you move up into the building, the offices, the hotel, and the residential, pulling some of those qualities and some of those materials up into the building. And then we're doing a lot of work with the State Department's overseas building operations. We have 5 embassies under contract. These are some of them. The one on the far left is the one we're doing in Tegucigalpa, Honduras, which is in construction. a new office building for our embassy in Bangkok in the middle, and we're just starting construction on a new consulate in Milan. And again, these projects have very strong security requirements, but at the same time, we're a guest in somebody else's country, and we want to create something that feels welcoming and speaks to some of the qualities that we've experienced there. So I just gave you a quick overview of some of the stuff that we've been up to, but I wanted to sort of focus it a bit on the challenges that we face today. We're all facing today in one way or another. And it's really influenced, especially over the past 5 years, how we think about how we work, how it should inform our design process, and also how we collaborate with others in the field. And the question is, why now? Well, we have a huge housing crisis. I mean, yesterday I read the median rent in Manhattan is $4,000. $4,000 a month. So we are well past pre-pandemic numbers. There's just not enough housing out there. And at the same time, we also are challenged with what's going on with the environment. So more people are living in cities. That's very much still the trend. There is not enough housing. And so where you're seeing prices going up and people can't afford, you're seeing a lot of people having to live on the street or look for social services. The other thing is the amount of embodied energy that goes into these buildings. By far, our sector has one of the largest impacts. The other thing that people don't really realize is there's a lot of forced labor in the material supply chain when it comes to putting buildings together. And this is something that I think, Dickinson could also, be engaged in, is starting to understand how we can have a more connected relationship with our supply chain. And I think data analytics program could play a big role here. Because without a resilient supply chain, we're going to keep having these problems. We're looking at 12 to 15% increase on top of what we typically see with construction costs as a result of being faced with a very unresilient supply chain. So the role of technology to help support us in creating that efficiency is something we think is really important. This sort of brings me, Bernadette, I told you I'd give you a plug for McKinsey, as if they needed a plug. But there was an article that came out in 2017 that basically showed a graph where construction in terms of innovation was behind farming and hunting. So hunter-gatherers are more innovative than what's going on in our industry. Now that's 2017. It has gotten better, but it's, when you talk about our space, it doesn't happen overnight. It's not a SaaS thing. You see returns after 18 months. That doesn't happen in the built environment. So these are some of the things that we face, inefficiencies on the job site, constantly re-estimating, trying to figure out why things aren't working, how we manage data. People are still using 2D information and they're referencing it. Job site safety, reworking, we're looking at close to 10 to 12% on top of your budget for reworking and mistakes done in the field. And that's not because of necessarily because of the contractors, it's how we all collaborate. And then there's the whole amount of waste. And then on top of this, and this is the part that a lot of people miss, but the community feels it, to do a building in a city, usually it's 3 to 4 years. So anybody who has to live near a job site has to put up with this congestion, this noise, particulate matter, and safety issues. So what we've been looking at for the past decade, based on some of the things that we've been doing with technology at SHoP, is how can we go from a construction approach to an advanced manufacturing approach? And so we're seeing some automation happening on the job site. We're seeing some automation happening in the architecture office. But how can we sort of break out of our siloed thinking and start borrowing ideas and concepts and technologies from other industries? So if you ever come to SHoP, one of the things you'll see besides a lot of models in the gallery is a lot of airplanes on the wall. We're completely connected with aerospace and use a lot of the same software that they use to manufacture aircraft. And so how do we use this idea instead of drawings, but this model, this digital model, what we would refer to as the single source of product data to manage the whole process through design to construction to post-occupancy. And it's something you don't throw away after you move from one phase to the next. And how do you use that model to instruct not only your design team and your consultants and help explain things to the client team, but how's that model used to help build the building? And so what we've found over the 25 years of our office is the most innovative things we did were really with very small projects. And this is part of, the waterfront project, our very first project we did out in Greenport, Long Island. This is a camera obscura. And a camera obscura is, it's like a big camera box that you can come into. It's completely pitch black. There's a little pinhole at the top that lets light in. It goes through a lens, the light hits a mirror, and it bounces a projection down onto a table. And it's as close as you can get to wearing 3D glasses. It's very cool. And what we decided to do is we would model that little building all in the computer. Every piece was modeled right down to the screw. And so what you see here is all the pieces you need to build that model. But the same digital model was used to build the actual model was the same model used to build the actual building. And so it was like, in a way, it's like IKEA for architects. Everything showed up as a kit, and the contractor basically bolted everything together. So this is the first example of design for manufacturing and assembly, and we did this in 2003. There were no plans and sections in the documents. It was all like looking at a model kit, axon drawings and things like this. But now, we didn't have this back in 2003. But this is the kind of software that allows us to visualize and share information with our client teams, whether it's through a headset or being in a fully immersive environment. And so we continue to do this, really innovate and push ideas on these small projects, and then the small projects would actually influence the bigger projects. So in this case, doing a project for, Art Basel in Miami using 3D printed processes, additive manufacturing, or terracotta, very traditional, hundreds of years old material, but showing how we could use technology to really bring these types of material systems into the built environment and designing them in a way that people could pick them up. And the exciting thing about it is it really brings this whole idea of human scale intimacy through the way that a material is put together. What's interesting about both these projects, the terracotta one is actually, because they're both designed for disassembly, is actually going to be part of the campus for the new consulate in Milan. And the Wave Cave is actually at the University of Nairobi as part of their architecture program there. So for us, it's really about moving out of our siloed environment and really engaging with companies that really are pushing advanced manufacturing. So we have people on our other company, which I'll talk in a moment about, former head of technology at Boeing, John Tracy, who ran the whole Dreamliner program. We've got people from SpaceX and Tesla, and it's really bringing these people in here and really gate testing our process. Now the thing is, it's not just about the software that's out there, but actually working with software companies to really beta test and evolve this. So whether it's with Dassault Systems CATIA or with some of the gaming software companies like Unity, really pushing this. But this is where it becomes really exciting, because one of the key things is making people comfortable with how you use this technology and actually have a lot of fun with it. Kids don't really have they have no problem playing around with technology. But when you start dealing with adults and who have $100 million budgets, and they're really concerned about meeting the schedule and the cost, these types of technologies really open the door. And what we found is it accelerates the decision making, and it also creates a much more collaborative shared relationship between how we design, but also how we share these designs, make decisions, and then bring them into the field. This, for example, it's amazing. We'll show up to a project and we'll have 10 different, we never show up with one thing. You know, there's never a ta-da moment. We show up with a versioning of different forms based on programmatic requirements, but then we show up at the site and you can actually see what it would look like on site. And that's when the client actually makes the decision, that's the project I want to build. And then we are able to take this information and actually go on the job site and work directly with the contractor and fabricators. And this is something that we learned quite immensely when we were doing the Barclays Arena in Brooklyn. And then getting right into your environmental systems and coding things. So it's not just what happens on the job site, but what happens after the building is turned over to ownership and the facilities team is able to use it. So this whole idea of model-based delivery. And I think this is like one of the key things, because our work should not be about projects, it should be about products. And the idea is that as something evolves over time and you build that building, data from that building, feedback from that building, which we sort of call the digital triplicate, feeds back into the digital twin, and that informs your next project. So you're really building off of experiences and knowledge and data, and it's an iterative process. This is something that we're not seeing right now in our space because, you know, typically, you know, the model doesn't go beyond. If you're lucky, it goes into construction, but it typically doesn't go on to post-occupancy, so you're not getting a lot of that feedback. But here, it's the wire mesh that's critical. That's where all the attributes of the materials are embedded into the model. So if I move one of those cords, it automatically updates the geometry of the materials, and it also updates the material frames next to it, so it's parametrically adjusting the whole model. And that's the kind of, when we did the camera obscura, we actually had to go in and manually change things. But now with parametrics, we're able to do that. And because the power of computing has come so far, we can now put all this information on our phones. And so I could show you later on if you're interested, but I have the whole digital twin of the Barclays Arena on my iPhone. And it's that kind of power where, you know, you can go into a meeting and pull something up. And what would be great is if somebody goes to a concert there and wants to know where the best fish tacos are, they can call it up and start looking, or where their seat is. So it has so many opportunities for this future of open architecture. And this I'll talk about in a moment because it's tied to our next coming. But this is something, I brought this up when the whole conversation of data analytics, because I really believe the fine arts department should have engaged in this process, is a visualization. We created, my wife who is a professor of environmental science at Yale, scratch built a fully immersive environment called Beam Lab. It's 360, her space has 12 projectors. And basically she could put you in a site all over the world, but she can also map data, overlay data, and start telling you what are some of the criteria, what are some of the performance requirements that might need to go into that building in order to work well in that condition. She's now working with the UN on this type of technology. But we found, when I taught at Yale, I said, this is the best way to teach students. I used to just sit at their desk and look at their drawings. But then they come into the space and they have their whole project surrounding you. And it's so visceral, it's so intimate. And so we found that when we did this in the office and we brought clients in here again, they're able to look at data in a holistic way and they're able to make decisions. And that's something that we think is really, really exciting. But the other thing that's really exciting, we're all doing it collaboratively, and it happens to also be sort of fun too. And then you can always create these 360s. And we think, you know, it would be really cool if Dickinson had one of these types of spaces here on campus. Egg Glue is a company that actually produces this technology. And so the possibility that data analytics would actually have a space where you could go in there and actually analyze data in the round. And here, John Cerrone one of my partners is giving a demonstration on assembly process. Now, what's really exciting about this is we can also take data from other centers, in this case from Google Earth, and I say, hey, I was in Bologna. I want to, let's see what it tells us about Bologna. And what's amazing is, you know, why does Bologna feel so good? What is it? What is it about the proportions, the width of the street, the loggias? So you can get into this data. Actually, you can even go on Yelp and it'll tell you where the best gelato is. But it's this kind of data where, you know, in our space, the developer always says, well, show me a comp. And what we love to do when it comes to urban planning is show comps from cities that we've all been in, whether it's Marrakesh or Bologna or London. And we're able to analyze this by breaking it down into a mesh where we can look at daylight analysis, height, and even more specifically, program. And when it gets to program, it gets really interesting because you start to see the marbling of different activities and different experiences within the different scales of these cities. And this is the kind of information that we could bring back to projects that we're doing in the office. So really, you know, you start modeling day one. You're taking data from previous projects, you're embedding it into the model. You can take cost data, scheduling data. It doesn't mean that your building is going to actually be built out of steel or concrete or mass timber, but you can run simulations and get a sense of what the challenges might be. And then you could make spreadsheets and really analyze it. This is the kind of, it's really about prototyping, virtually prototyping multiple times before you actually, you know, get into the actual design and construction of a project. So really quickly, I'm going to just go through this whole idea of, you know, how advanced manufacturing to us is the key to how we start dealing with these issues of the environment and housing and creating a more resilient supply chain. Is that when we were hired to do the Barclays Center, we started out with the facade. There's 12,000 panels on this building, they're all different. And so we didn't tell the fabricators who were bidding the job up front. We said, well, maybe there's 10, a family of 10. And everybody's, okay, we can handle that. But as we started working with them and using the software to really efficiently nest all the material, look for the optimum roll size of steel, we started to realize as long as the panels were water jet and folded and weathered chronologically, the computer didn't care if everyone was different. So we created our own automated shop tickets. We talked to the fabricator. This is the other thing that's important. You know, architects aren't supposed to be involved in means and methods, but if we're really going to break down these barriers, we all have to work together and manage risk together in a collaborative way. And that sounds scary, but the way it is right now, everybody silos themselves from risk because they feel that this is the best way that they'll protect themselves. But as a result, costs keep going up, mistakes keep happening in the field. So by creating this visual artifact, everybody is working the problem together. So it's really taking advantage of human nature and changing sort of the behavior. And we're able to monitor where those panels are, whether they're still in the factory being fabricated, whether they're being weathered, or they're on the truck or on the building. And we can see where there's a problem. And of course, ownership goes, oh, you know, I'll cut a check for this percent because I can actually see in the model where you are with the project. And so in case this is the CATIA model that we created for this project. So what was really exciting is you're saying, okay, we did this in the United States, but can you do this in South Africa? And so we won an innovation hub in Botswana, Africa. And one of the reasons they hired us, they said, we really want you to use this technology on our project. We want the tech transfer. And so we met with a fabricator in Cape Town who won the bid, and we had one of our people, Rebecca Lorenz, went over there, spent 2 months helping them to modernize their plant. And then we generated all the fab tickets. Again, by this time, we could have everything on our phone. We also did digitization, where you go in and you digitize the existing condition to make sure all the steel hangers are in the right place. We learned this off of Barclays when we found out 16% of the hanging clips for the steel panels were in the wrong place. And so the iron workers went up there, cut them off. We showed them on our iPad where they needed to go, and they put them in the right place, and every panel went up right the first time. So you can imagine when those big mega panels showed up the office and onto the site and the clips weren't in the right place, you had to put them down on the street somewhere. And that's where everything starts to turn into a train wreck. So we've actually just finished digitizing the whole USS Intrepid because they want to open the whole ship up to the public, but they can't cut bulkheads to meet ADA requirements and fire safety. So we're looking at this whole concept of a virtual museum, so you can actually move through the whole ship. And here, again, sort of like the camera obscura, the pieces were all cut, folded, broken, and then they were boxed up and sent to the site, and they were put together in the parking garage underneath the building. So again, trying to create a safe work environment, but also using, a lot of the techniques that we developed from our previous projects on this project. And this facade was 10th the price of the Barclays facade, but it was more complex. So the opportunity of really looking at how we can work with global fabricators to really advance this approach is something that we're all very, very excited about. And then how we can take bio-based materials like mass timber, cross-laminated timber, where we can actually mill all the components. It's like a log cabin, but much without seeing the logs. Everything's composite systems, and being able to put a building together very quietly with very few people on the job site. So everybody's in the factory getting all skilled up, and you're really keeping the job site really quiet for the people who live there. So this brings me to the tail end of the talk. So when we were doing Barclays, the developer Bruce Ratner at Forest City said, I have 6,000 units of housing. That was part of the agreement they had with Empire State to do this arena in downtown Brooklyn, half of which had to be affordable. And he says, we're not going to be able to do that by just doing everything conventional. So he said, SHoP, would you be interested in, collaborating on a modular high-rise tower? So we basically, started working in model. We met with people who were from the modular volumetric environment. We started engaging with our engineers and understanding some of the structural challenges of doing a 32-story building. But also starting to understand how you delegate, how you break this down and communicate with the different consultants, the different fabricators, the people who are doing the conventional work on site, and the people who are doing the work in the factory. Even understanding how you break a building down. There's 23 different unit types, hundreds of variations on a unit type. And then understanding all the different components. So really productizing, an architectural process, moving from a project to a product-based approach. And this is a Revit model. So a Revit model, for example, is what typically architects work with, but you can't actually send files from this model to a fabricator. It's really a representational visualization device. The models I was showing you earlier use CATIA, Dassault Systems CATIA, where we can actually take information from our models and send it directly to the fabricator's machines. So what we learned from this whole process was, as some of you who are involved in tech understand, if it works the first time, then you're not really doing anything new. There were so many problems with this project. We learned everything what not to do. And part of the problem was the general contractor that was hired to do this basically took the job site and moved it into the factory. So we weren't even manufacturing. We were just doing construction under a roof. The other thing is there was a lot of material systems that you normally see on the job site. The same ones were being done here, like sheetrock, chipboard, drywall. That is not a material you see in factory production. You put up a wall and you put some tape, you put some spackle, you sand it, put some more spackle, sand it again, then you prime it, and then that doesn't work when you're working in a manufacturing environment. It just slows everything down. So you start to think about what are the kinds of material systems that you need to use. So from this whole process, but it was great. It was a union job. It was made in Brooklyn. People got upskilling. It's a great story. but we realized this wasn't going to impact, or address the needs of housing in our city. But what was beautiful about it is it doesn't feel or look like a modular building. People could walk by and they wouldn't even know that there are 900 mods stacked 32 stories tall with a mass-tuned damper, because this building, embodied carbon, is much lower than a concrete building. So already we're sort of addressing some of those challenges. But there were just so many things that we learned what not to do. And so what we decided to do, 4 years ago, one of my partners, Greg, was down in Miami giving a lecture. And there were people from Pininfarina in the audience, and they're world famous for their coach design, mainly for Ferrari, but they do it for BMW and everybody else. And they've sort of expanded into interiors and architecture. And Greg was talking about this project, and they said, hey, it would be great. We do a lot of advanced manufacturing. Why don't we JV on something, joint venture on something? So my twin brother and I flew out to Turin and went through their whole system. They were using CATIA like we were using CATIA. But they have a gate review system. In manufacturing, when you're developing a new product, you have a gate review. And you have to sort of understand, is this working? And if it doesn't, then you go back to the previous gate in order to version it and prototype it properly. So what we learned is there are a lot of common steps that we were doing with what they were doing with cars. And that's when we started talking to people who were really interested in investing in AEC. And one of them had a lot of connections with Boeing and with Tesla, SpaceX. So they came over, they actually walked through our building, and we started saying, hey, maybe we'll do this. So 4 years ago, we started a company with the whole idea to address housing in our cities is to do manufactured, volumetric, high-rise, mid to high-rise housing. No, so not single family, not what's referred to as 5/1s, 4 or 5 story buildings, but really 10 to 32-story buildings, all manufactured in a controlled work environment. Very much like what you see done with the 777 and all airframes today. So this is the traditional model you see. All the materials and everything is brought to the job site. And this is what you see with aerospace and automotive. You have a tiered supply system. And here, the key thing is when you do a high-rise building, you can't single source it. What that means is you can't rely on one supplier or one builder who's only able to do this kind of architecture. Because if something goes wrong, you've got to be able to pivot. Because you've got all this money that's being financed, and you've got to be able to pivot and go to another supplier, another contractor to help support the mission. And so it's an open source supply chain. So every component in the project is modeled in the computer. And what you see here, they don't all show up as like just sealed boxes. This is a studio, just to give you so it's not, we do also 1 bedrooms, 2 bedrooms, and 3 bedrooms. But what you see here is this is the CATIA model, and all the components that you need to manufacture this studio apartment is captured in this single source of product data. And it's all tracked through a platform. So as Elon Musk said, we're a tech company that happens to make cars. SHoP, in a way, is like a tech company that happens to do mid to high-rise residential buildings. And so it's really looking at how the platform adopts and evolves over time and informs how we connect with our fabricators, how we connect with the bank. Everything from zoning to financing is done through this process. So the idea here is you basically buy a building like you buy a car or an airplane. But there's a lot of data that backs up your decision making. It's sort of like when you order a car now, you say, well, I want this and I want this. So there's a lot of detail that goes into that. So this is one of our first projects that we're working on in terms of the development deal for a mid-rise building in Harlem. And so what we did last summer was we decided we're going to test our supply chain and do a 1 bedroom. because we have a prototyping facility in Harrison, New Jersey. So here you see, again, the model broken apart. There you see the actual one bedroom. And what was really cool about this, and nothing against builders, but we wanted to see if we could put it together ourselves. There was one licensed electrician, but our MEP engineers put all the piping and all the ductwork together. They installed, the steel was actually fabricated in Venice by Chimolai. They did the culture shed and the Oculus in Lower Manhattan. Really fantastic fabricators. The tolerances, 5 millimeter tolerances. We're not talking about inches or quarter inches here. Really manufacturing tolerances. But what's really exciting is that you got designers, engineers who are actually putting it together. And here you see them connecting them together. And there's the facade. So when the mod shows up at your job site, everything's inside, including your appliances. So your flooring's in, your appliances, your MEP systems, everything. The only thing that's not done is you have these mate line hookups. So we would bag them up, they would go in your closet, and then you would connect the pipes, and you would do all the framing around the door thresholds. But here you get a quick sort of view of what that space looks like. Now, one of the key things about this space is there's no drywall, no sheetrock. So it's designed for disassembly. So there was a case when one of the MDF panels showed up and was damaged. And Natalie and Alex pulled it down. In 5 minutes, they had one from our attic stock right up on the wall. So for us, what's really exciting about this is that we can look at different materials. It doesn't have to be the same facade. It doesn't have to be the same finishes. It doesn't have to be the same appliances. You can actually have a great deal of difference and mass customization. And for us, that's really important because no developer wants their building to look like their neighbor. Now, this is, because I'm almost done here, this is what's really cool. Because at the end of the day, it's the customer that's critical, the owner. And to be able to go into your apartment, have your headset, and you can actually see what's behind your walls. Imagine if facilities here at Dickinson had that. But you also embed sensors. So you know when things start to go offline, maybe you get a leak, and you don't have to wait for it to stain your ceiling tiles. You actually know it before it starts getting out of control. So you can actually go in there and access that. But it also helps the homeowner start to understand what they own and how they can sort of monitor it. And in this case, I can, again, show this on my phone, but you can click on it and really understand, what went into putting your home together. And if you want to upgrade, then, Assembly would be able to, make those upgrades based on our connections with our supply chain. So at the end of the day, I think the big story for us is I truly believe that we wouldn't have come to this if a majority of us hadn't had a liberal arts background. If we had just gone from high school right into architecture. Because my partner, Greg, he has a finance degree from Villanova. Corey Sharples, my sister-in-law, has a business degree from University of Maryland. Kim had a fine arts degree from Hamilton. I had fine arts in history and a minor in poli-sci from here. So I'm good at cocktail parties. But thank God my twin brother, got a structural engineering degree so that we knew that things would stand up. But what's happened is when we go into projects, we're leveraging those other skill sets, and it's really influenced our staff in a really great way that people just don't remain pigeonholed and siloed in their thinking. They're looking outside of our borders to other industries to help support these kinds of wicked problems that we're all facing. So this is one of the things that I'm grateful for Dickinson, and thank you for listening. I think we have lunch, so. I guess I could take one question if somebody has a question. How long does it take to build the module? So that's a great question. So The key thing that a lot of it, so we just closed on our Series A, $40 million with Fifth Wall anchoring it, but also a major global developer is also part of that raise. And when we talk about cost, we say, no, we're competitive with conventional, but we're going to deliver it in 40 to 50 times quicker. Now, that's not going to happen on the first project, but the thing is, as we keep doing, because there's plenty of history, being a history major, you know, you look at the Liberty ships that Kaiser did in World War II. I mean, he was able to get one down to 4 days. Not that I would want to be on that ship, but the fact is, if he could cut a ship construction from 2 years down to 6 months, your carrying costs are impact millions of dollars, and plus you can start generating revenue much earlier. So one developer said to this, Marianne Gilmartin, said, if you can guarantee me price and guarantee me time, I'm willing to pay a premium. And that's the kind of incentives. So we're looking at, you know, the end goal is really half the time. And as our teams in the Tier 1 facility, and the Tier 1 facility doesn't make anything. They take all the sub-assemblies from the other tiers, and it's IKEAing it together. So you're basically bolting, no welding, no spackling, no taping, no painting. All finished things. So what I think is also really exciting about is it all can improve over time. When you build a building at substantial completion, it starts at state of decay. I know you go, I just paid all that money for a building and now it's starting to but you know, they get worn out. And the whole idea is like with aircraft, you know, it's an open architecture. So when the avionic technology improves, you get an upgrade. You don't throw the whole airplane away, you upgrade it. And that's what should be happening with our built environment. We should be able to upgrade and keep testing, get data feedbacks, and that will impact cost and efficiency. Okay, thank you all.